Dear viewers, we will discuss the number of degrees of freedom, also called movability, for planar mechanisms. The number of degrees of freedom is defined as the number of input parameters that to be controlled to bring the mechanism for useful engineering purpose. This is a simple 5-bar mechanism with link 1 is fixed and each link is connected to the other link. So this is called as a pair. The link 1 and 2 will form a pair, link 2 and 3 will form a pair, link 3 and 4 will form a pair, 4 and 5 will form a pair, and 5 and 1 will form a pair. And all the links are connected by a binary joint, and the links will have a turning motion at this binary joint. Now we find the number of degree of this 5-bar mechanism. When the links are not connected to each other, each link will have 3 degrees of freedom, 2 translational and 1 rotational motion. So each link will have 3 degrees of freedom when they are not connected to other links. Now total degrees of freedom of this 5-bar mechanism is written as each link will have 3 degrees of freedom, 3 into n minus 1, where n is the total number of link. Here it is 5, minus 1 is the link which one is fixed. So we will reduce the number of total number of link by 1 as one of the link is fixed. It won't have any degrees of freedom. So now the total degrees of freedom of this 5-bar mechanism is 3 into n minus 1. Considering the links are not connected to each other, they are independent. Now as the links are connected to each other, the degree of freedom of this 5-bar mechanism will get reduced. So we will introduce minus. Here number of joints, binary joints are 1, 2, 3, 4, 5. 5 binary joints. The 5 binary joints are called as lower pair. Sorry, here it's not be 5. The 5 binary joints are called lower pair because they are the turning pair. The lower pair is one which has area contact or surface contact. Each lower pair will have 1 degree of freedom. Thus, they will destroy remaining 2 degrees of freedom. So, we will introduce 2 degrees of freedom into J, where J is the number of binary joins or lower pair minus number of higher pair, or the pair which has, the higher pair is one which has line contact. The higher pair will have 2 degrees of freedom, thus they will destroy 1 degrees of freedom of any mechanism. Now this equation is called Kutzbach criterion. For defining the number of degrees of freedom of any planar mechanism. Here, n is the number of links is equal to 5, and j is the number of lower pair is 1, 2, 3, 4, 5, and h is the number of higher pair. Here it is 0 since no higher pairs are here. Now applying this value in the above degrees of freedom equation gives degrees of freedom is equal to 3 into 5 minus of 1 minus of 2 into 5 minus 0 gives 3 into 4 minus 10 is equal to 12 minus 10 is equal to 2. So the number of degrees of freedom of this 5-bar mechanism is 2. Thus 2 inputs theta 1 and theta 2 need to be controlled to have a constrained motion for this 5-bar mechanism. Thank you. If you like this knowledge sharing, please click like and subscribe to our channel.